And now, it's time!
We will discuss this week with a brand new topic, which is properties of normal curve, and then we will try to find the regions of this normal curve and the areas under normal curve. For your task, please download this what we call Z table. I will explain to you later what is this Z table. So if you are ready, we will start. Okay, welcome back. First, we will discuss properties of normal probability distribution. Now, when we say property, we are to discuss its characteristics of a curve, the curve of the normal probability distribution. In some other book, this curve is called as bell-shaped curve. In some other book, this is normal curve, and in other book, this is called as bell curve. So the first characteristic or property is the distribution is bell-shaped. Looks like a bell. Right? All graphs or curves of normal probability distribution looks like this. So, number 2, the curve is symmetrical about its center, meaning if we divide this curve into two equal parts, the curve on the right side should be of the same curve of the left side, meaning the curve here is just a mirror of the curve on this side. Whatever the image portrayed here should be the same as the image here. They are symmetrical. They are of the same curve, the same width, the same height. So that is called symmetrical. About its center, meaning at the center. Number 3, the mean, the median, and the mode coincide at the center, which means at the center of this normal curve lies your mean. And if it is normal probability at the center, which is mean, there coincides the value of your mode and the value of your median. Okay? Let's continue. Number 4. The width of the curve is determined by the standard deviation of the distribution. Now, the width, which means the thickness of the curve, is determined by the standard deviation. In a normal curve, there are 6 z-scores. We have -3, -2, -1. Your mean is 0, then +1, 2, and 3. If we make the distribution bigger, your graph will probably like this, meaning the top portion becomes lower and lower while the base area becomes wider. That depends on the standard deviation. Now, if the standard deviation is smaller, then your top portion becomes higher and higher. If we widen the base, the top portion becomes lower. If we make the standard deviation smaller, then the top portion becomes higher. Why? We will discuss that in the sixth character. But before going to sixth property, we will discuss first the second to the last property, which is the tails of the curve is asymptotic to the baseline. What do we mean by asymptotic to the baseline? When we say asymptotic, the tails of the curve when we say asymptotic, the tails of the curve tends to be closer and closer and closer to the baseline or the horizontal axis. It will tend to be closer and closer, but will never touch this axis. It will come closer and closer even if we extend this up to infinity. The tails will never touch the baseline. That is what we call asymptotic to the baseline. Alright? Now the last one. The total area under normal curve is 1 unit. This is equal to 1 unit. That is why if we try to make this a little bit closer with each other, the standard deviation, it becomes higher and higher because the area must be equal to 1. The proportion, the concept of proportion is applied into this character. Try to compare. If we widen the base, the standard deviation, widen, the top portion becomes lower. If we make the standard deviation smaller, the top portion becomes higher because the area under normal curve is equal to 1. Okay? Okay, this time we will discuss z-scores, then how will we use the z-table, then we will locate regions under normal curve, and we will find the regions that is located in the normal curve. Now, first of all, what are z-scores? From this normal curve, we all know that the center is our mean. The 3 numbers to the left and to the right of the mean are called the z-scores. 1, 2, 3, -1, -2, -3. Now, these numbers are equidistant from the center. they have the same distances from the center up to each of these z-score. Like in the Cartesian plane, all the numbers there are equidistant with each other, the same concept. Now, how about this table? How do we use table? Now, if we are to find z equals 1, we're gonna use z table in finding its area. And how will we locate this z1, this region z1 into the curve? Now, z1, since it is exactly 1, this is your region. This is the region of z-score is equal to 1. Now the problem is, how do we find the area of this shaded region, which is z1? Now by the help of z-table, we can find the area of this. We don't need to solve, but we just locate it in the z-table. How do we do that? But before we use the z-table, we will transform first this number into 3-digit form. Here is my 3-digit form. So this becomes 1.00. How do we get the area? If you have downloaded the z-table, it looks like this. We have z, we have numbers here, 1.0 up to 3.9, and in the top portion we have 0.00 up to 0.09. Now, since we have to find z equals 1 or 1.00, the first 2 digit belongs to this area. Okay, so we will find the first digit in this side, and then the last digit is on the top portion. So how will we find this? We will get its intersection. Since 1.0 is on this part, right? And then the last digit is here. Therefore, whatever the number here is the area of z equals 1. Now, how about if we have to find z equals 2.34? So at the middle portion, we will find another set of numbers, 2.0, 2.2, 2.5 up to 3.9. Okay, find this 2.3. So this is your 2.3, right? Then find the last digit, that is here, and then get its intersection. The intersection is here. So whatever the number here is the value of your z equals 2.34. Right? Any question? No question. Then how about if we are to find areas which are not adjacent to the mean? Example, find the following. To the left of z equals 1.13. Okay. To the right of z equals 0.70. Okay. How do we locate this region? First, we are to find this positive 1.13. So this can be found here. Label it 1.13, and then the phrase states that to the left, since it is to the left, then we will shade all the left side of this region. How do we get its area now? To find the area, we will find first the area from the center to 1.13, and it will be added from the area of from 0 to 3.09. Get the area of this one plus the area of this one equals the total area. Z equals negative 3.09 plus Z equals 13. So how do we get this? We use the table. Then whatever the number that coincides to the intersection will be substituted here and also here to find the total area of the shaded region. Now how about number 2? Find 0.43, that is here. Label it as 0.43, and then to the right, which means all of the right side of this region is shaded. Now how do we get this? Since the region is not adjacent to the mean, so you get first the area of the half of the curve, as we have z equals 3.79, then subtract the area from 0 to 0.43 minus z equals 0.43. Same process. Okay, we have an area which is adjacent to the mean, and we have also area which is not adjacent to the mean. Another problem, number 3. Find the area which is in between z equals negative 2.9 and z equals negative 0.18 or 1.18. How do we locate this region? Okay, so where is 2.72? This is closer to negative 3. Label negative 2.72. Then where is negative 1.18? That is closer to negative 1. It's negative 1.18. And this is the region. How will we find the area? Simply subtract the area from 0 to negative 2.72 by the area which is from 0 to negative 1.18. By the way, even if the z-score is negative, still we are to find its area to from the z table. There are no negative values there because we are talking of area, and if we are talking of area, there are no negative areas, as well as there are no negative heights, negative weights. Negative are only found on temperature. But if we are to find area or length or width, there are no negative values. That's why even if the z-scores are negative, it yields a positive result. So what will we do here is we will find the area of negative 2.72 and we will subtract it by the area of negative 1.18. This is congruent to, look at the table. This is also congruent to from the table, and then you can find the value by subtracting the value of negative 2.72 by the value of the region of negative 1.18. For this week. By the way, this coming synchronous class, please try to bring with you your Z table in order for us to have a good interactions. Thank you and God bless. Alright, that is all for this week, and I hope you understand our topic. I hope that the discussion is clear to you. But if there are confusions, again, I am begging you to ask these questions on our respective group chats. Okay. Once again, God bless and keep safe.